do mountains form?
Thanks.
We see them in just a moment of time, but they form over millions of years. Mountain belts extend for hundreds, even thousands of kilometers, and their structures penetrate deep into the earth, so their size and age make their formation difficult to understand. French geologist Jacques Maladier built sand models that mimic the formation of mountain belts and allow scientists to study this complex process.
In order for an experiment that runs for only a few minutes, but represents natural phenomena that happen over many tens of millions of years, we have to choose a material whose deformation behavior does not depend on time.
What makes the site so ideal
Le sable est un très bon matériel. Sand is a very good material for simulating rock deformation. In the experiment, the different stratigraphic layers, which represent the sediments and the continental crust, have different mechanical properties. We mix the sand grains with a finer powder, which increases the sand's resistance to deformation. Thus, we have heterogeneous material made up of more resistant layers and less resistant layers.
Mountain belts are created when continents collide. In this experiment, we see two continents separated by an ocean.
Once we've cleaned off exposure so we can see
Now watch what happens as the plates converge.
we commonly will grid a surface with strength.
As one plate subducts or dives beneath the other, the ocean basin closes.
And then we wind up logging or drawing directly
The
on
continental crust, which is lighter than oceanic crust, cannot be subducted.
scan this into a computer.
Instead, as the continents collide, the crust thickens and is forced up. Note how the sand is folded and faulted.
This is one of the most unique outcrops in this
We
area.
see similar structures in the rocks in
well-bedded
mountains.
stratigraphy.
One important factor not accounted for in this model is erosion. Erosion exposes the deformed rocks that were once deeply buried in the mountain belt.
To some stratigraphic
The
level
green sand represents the rocks of the ocean basin.
by more deposits.
Note that it's been trapped between the two
Once we
continents,
study how
marking their original
fault has
boundary.
affected the sediments, we'll try
These
to
too we see in
reconstruct,
mountain belts.
faulting history is very important. to
It's
try to
very
date
difficult to
precisely
understand the deep structure of a mountain belt by direct observation.
We like to find sites that have charcoal
The
or
sand model allows
we
us
use
to
the
compress
radiocarbon
time
dating
and
method
space
to date
and
the individual
simulates
pieces
the
of
internal
charcoal
structure
or to
of
date
mountains.
peak horizons.